Hello everyone. This exercise is about common versus independent risk. First up, we have a bunch of information that I will go through now. Info. We just call it info. First up, we have bank 1 and we have a bank 2, as it seems. We have bank 2 right there. Okay, in bank 1 we have 150 loans outstanding, each for loans amount of loan per loan, which is €1, 1 million euro, and it is expected to be repaid today. So we are not considering time value of money. That is what this part is saying. Then we have, I will just jump over this for a bit, because we can see that each loan has 10 probability of default, where nothing is repaid. The chance of default is independent across all the loans. We have the same down here that also have a 10% probability of not being paid back. So this is common for both banks. But for bank 2, we have that loans outstanding. This is only one, because we have this only one loan, but it is worth 150 million euros. We have the probabilities here. Probability of default is 10%, and a probability the probability of being paid back would be the opposite of that, like the probability of default 1 minus the probability of default is the probability of being paid back, which would be 90% probability. Great. Now that we have that written, we can go to the first question. In the first question, we are asked to calculate the expected overall payoff of each bank. So for that, we will use the expected return, or the expected mean return calculation for where the expected return calculation is based on probabilities, where we can use the following equation. The probability of return of one outcome times the return of that probability. So when we do this, we can just plug our numbers in the calculation. So the expected return for bank 1 would then be, we have for the default we have 10% for being paid nothing, plus 90% for being paid 150 times 1, which is like 150 loans outstanding times 1, which is like, which adds up to 150 million. And we can do the same for bank. The return for bank 2, where we have 10% times 0, which is, there's 10% probability for the loans to be 0, and 90% probability of the one loan being equal to 150. And when we plug these numbers in, we get bank 1, bank 2, 10% times 0 plus 10% times 0 plus 90% times 1 plus 150 times 1. Okay, and for bank 2 we will do the same. We have a 10% probability of default times the 0 return, which is the probability of default is 0, but it's for the 10%. And then we have the 90% for being paid back times the one loan outstanding times the size of that loan, which is the same. So we get an expected return of 135 for both the bank 1 and bank 2. Next up, we wanted to find the standard deviation of the overall payoff for each bank, and to find the standard deviation, we know that the variance squared is the same as the standard deviation. So first up, we wanted to find the variance, and the variance can be found by this following formula. Okay, so for the bank 1, we have that the variance for one loan, we have 150 loans. For one loan it would be 10% of default, 0 minus this is important because there is 150 loans. We know that 130 divided by the 150 would be the average for one, or that would be the average for, that would be for one loan, plus 90% times and we do the same here. And to find the standard deviation of this, we would have to to square the variance. Moreover, we know that the overall standard deviation, or the standard deviations, the average of the independent identical loans would be with risk, that would be the same as the standard deviation for one loan. Standard deviation for the identical divided by the squared observations, or the squared number. This is the other formula that is needed to be used for calculating the standard deviation of the overall payoff for bank 1. Okay, so when we have this, we can calculate the standard deviation of the overall payoff of bank 1, which is the same as the average of independent identical risk. Not sure this is possible. No, it's not. So we just instead take the standard, the square root of the variance of each loan in bank 1 divided by the square root by the number of loans for bank 1. Okay, I hope you follow me. I will use Excel for that, otherwise it will be a bit messy. But the variance and the standard deviation and the standard deviation of the numbers. Oh, sorry, the square root of the number of observations. First up, we have the variance. I will calculate that right now. And what we did, I'll just make some space so I can see my outline, or what I have written in the Word document. So I would take 10% where the observation would be, or the outcome would be 0, minus the average of for the 150 loans, plus 90% probability of the loan being 1, minus the average of the that gives us a standard deviation of 0.3. and the square root of 150 would be 12.24. So the bank 1 standard deviation, the overall standard deviation, would be be 0.0244 or 9. Then I don't have to round down. So the overall standard deviation for bank 1 was then found to be it is a big numbers, so I just have to make sure that I'm not doing any mistakes. So we have this, this is correct. Then we have the average independent, the standard deviation of the independent loans with identical risk. So the first one would be this would add up to something like 9.90, and this would be 0.3, and then we have the then we have this number, which would be the same as saying 0.3 times 12.2474, and that would be enough, I think, which would give us an average of 0.024494. Maybe make it like that. Oh no, actually not, because there's a 0. Okay, this is the amount. This is the number that we were calculating, just to the square root of the number of loans would be the square root of 150, which is 12.24745. Great job. Then we get this amount. Sorry for not being so consistent. Then we wanted to find it for bank 2. The standard deviation for bank 2, because there is only one, but I'll show you. We can just use the same calculations. So we have bank 2. The variance would be the same. Okay, I'll just write it into the text again. So the variance for would be 10% of 0 minus how much was that? Of 150. No. 0. For being 135, and because there's only one loan, this would just be we would not have to take the average of each loan, or the average per loan, times 2 plus 90% times 150 minus this would give us 10% times 0 minus 150 plus 90% times times oops, this is not correct. This should be this one, and this should be 150 minus 135. So this squared of that would be 45, and when you square the 150, if you square 100, if you square 1, you will get 1, so the average would be 45. So now we get it. The standard deviation of the overall payoff for of each bank would be 0.02449 for bank 1 and 45 for bank 2. So the whole idea is that when you have a lot of small loans, you'll get a smaller standard deviation. Hence, the loan would be less risky, even though the average, the expected return is the same. I hope that helped. Otherwise, write me a comment, then I will try to help you even more.